Hello everyone, this is your instructor Professor Parwar here. Welcome to module 3, which is about kinetics of particles. So before we talk about kinetics of particles, which essentially relates forces with the motions of particles, let's do a quick recap of what we talked about in module 2, which was about kinematics of particles. So let's do a quick recap. So recap of module 2, kinematics of particles. So number one thing that we did in the previous module was we modeled objects as particles. So things as large as aircraft could be treated as particles. Things as small as electrons could also be treated as particles. And basically what we said was that all their mass was concentrated at a single point. What resulted from that was that particles could not have rotation. So they could not have no rotation. So we'll call it no rotations. What that means is that they were not allowed to change their orientation, because if you don't have a shape or a size, there cannot be a change in orientation. That is not to say that the particles could not move along circular paths or curved paths. So they could do this, and we know that velocities would be tangent to the path, but they were not allowed to change their orientation, as would be the case for an object which has shape or size. So for example, this particular square, it could be in this position. After a while it could be in this position, and we say that it has rotated because if you look at any edge of this object, it has changes orientation. So it's making an angle of 90 degree from horizontal. Here it could be making an angle of 45 degree, and we say that this is a rotation. Okay, the other things we talked about in kinematics of particles was we talked about three primary quantities: position vector, differential displacement vector, velocity, and acceleration. And there were three coordinate systems in which we investigated each of these three quantities of interest. The coordinate systems were Cartesian, tangent normal, and polar or r theta system. And we looked at the velocity expression, acceleration expression in each of those coordinate system. And we said velocity was equal to dr over dt, and acceleration was d2r over dt2, which is same as dv over dt. So if you know r as a function of time, and r could be in turn given as three components in three-dimensional coordinate system, or two components, so this could be given as d over dt as xi hat plus yj hat, with the understanding that both x and y would be function of time. So if you know r given as xi hat plus yj hat as a function of time, you could differentiate it once and get the velocity. And if you get the velocity, then you could differentiate the x component of velocity and y component of velocity, which would also be function of time, to get the acceleration. However, things are not that simple. Most of the time you will not be given the position vector as a function of time, and you would be able to calculate the velocity and acceleration, but you would most of the time be given maybe acceleration, because that's a quantity that you get actually more naturally. Then you can integrate it to get the velocity, and you integrate it further and you can get the position vector. For the tangent normal system, the starting point was slightly different. We started with the expression of the velocity, and that we said was tangent to the unit vector. We call it et hat, and acceleration was given by v dot et hat plus v square over rho en hat. So it has two component, tangential component and normal component. V dot indicates the change in speed over time, while v square over rho indicates the change in velocity direction that gives rise to this particular component of acceleration. In polar coordinate system, our starting point was the position vector, okay, which was given as r er hat, and then velocity was obtained as r dot er hat plus r theta dot e theta hat, and acceleration was a long expression r double dot minus r theta dot square er hat plus 2r dot theta dot plus r theta dot e theta hat. So that, in summary, is what we discussed in module 2. Okay, so if you remember this much stuff, you actually remember everything that needs to be remembered about module 2, kinematics of particles.